Hi everyone. In the previous video, we discussed the basic rules that you need to consider while multiplying two matrices. Now in this video onward, we'll see a complete program to multiply two matrices. So let's see how we can do this. At first, we'll declare three arrays. The first two arrays represent the matrices and the last array P represents the final product that we'll obtain after multiplying the two matrices. And after declaring array, we'll declare some variables. Here R1 and C1 represent the total number of rows and columns that our first matrix will have, and R2 and C2 represent the total number of rows and columns that our second matrix will have. And we'll be using some loops, so we'll use I, j, k as our counter variables. And after this, we'll check the order of the matrices. As we have discussed before, in order to multiply two matrices, the number of columns of the first matrix needs to be equal to the number of rows of the second matrix. So we'll write some block of code that will test the order of the matrices. And after this, we'll input the value for the two matrices. So here this block of code will write this block of code to take the input for the first matrix. Here R1 denote the total number of rows that our first matrix will have, and C1 represent the total number of columns that our first matrix will have. So the value of I will start from 0 and it will go up to R1, and after each iteration the value of I will increase, and after this the value of j will also increase from 0 and it will go up to C1, and after each iteration the value of j will also increase. And inside this I have written a printf statements. Here this block is written just to print the index of the element that we are entering, and I've assigned the address of the first array because we are taking the input for the first matrix. And in order to take the input for the second matrix, we'll write this block of code. There's a slight change. At the place of R1 we'll place R2, and at the place of C1 we'll place C2, and here we'll assign the address of second array B. So this block will use to take the input for the matrices, and after taking input we'll display that inputs. So in order to display the elements, we'll write this block of code. So inside this we'll just write the printf statement, and because we are printing the value of first array, so we'll write the first array here, and printf/n because after each iteration we will be printing the values in the new line. And this block of code will print all the elements of our first matrix, and in order to display all the elements of the second matrix, we'll write this block of code. So this is how we'll display the elements, and after displaying the elements, now we have to multiply the elements. So we'll write this block of code to multiply the two matrices. Let me make you clear with this assignment operator. So this is an assignment operator which is equivalent to this statement. So you might be clear with this statement. Suppose we have the matrices A and B, and according to the rule, the first row of the first matrix is multiplied with the first column of the second matrix. So this block of code will represent the first row, and this block of code is used to denote the first column. And here the new variable k is used because we have to multiply these two elements. According to the rule, 1 should be multiplied to 1, and 2 should be multiplied to 2, and 3 is multiplied with 3, and finally we'll add all the three products and the final result is obtained. So in order to do this, I've written this block of code, and after this let me make it clear to this block of code. In the first iteration, the value of I will be equal to 0, and as the order of this matrix is 3 cross 3, so the value of R1 will be equal to 3, and this statements here gets true. So the flow of control will now shift to this block of code, So the value of j will be equal to 0, and in this case the value of C2 is 0 because the order of this matrix is also 3 cross 3. So the flow of control will now shift to this block of code, and in this case also the condition gets true. So now the flow of control will shift to this block of code. So in this case the value of I is 0 and k is also 0, and again the value of k is 0 and j is also 0. So this block will point to this two elements, the first element of the first matrix and the first element of the second matrix, and the value of sum will be equal to 1, and after this the value of k will increase, and here this condition holds true. So now the value of I is 0 and the value of k is 1, and again the value of k is 1 here and 0. So this block of code will point to this value here. So 2, now 2 will get multiplied to 2. So the value of sum will now be equal to 4, and the final value of the sum will be 5 because 4 plus 1 equals 5, and after this the value of k will increase and it will be equal to 2, and again the condition here holds true. Now this block will point to this elements, so these elements will now get multiplied together, and the final value of the sum will be equal to 14, which will be stored at this place of the matrices. I hope you are clear with this. Now let's see whether this works fine or not. So I have written the code here. At first I have declared 3 arrays. Size of all array is 10, and I have declared 3 variables I, j, k for looping, and the value of sum is initialized 0 at first, and these are the variables that we have used to take the order of the matrices. And after this I have just returned the message in order to take the order of the first matrix, and this block of code to take the order of the second matrix. So we'll only multiply the elements if the total number of columns of the first matrix is equal to the total number of rows of the second matrix. If this condition here holds true, then only all the statements inside will get executed. If this condition holds false, then we'll simply print a message that we can't multiply the matrices. So here this block of code is used to take the input for the first matrix. We have discussed it before, and this block of code is used to take the input for the second matrix, and this block of code will be representing all the elements of displaying all the elements of the first matrix, and this block of code will display the elements of the second matrix, and this is the main block of code that we have discussed before. And at last we'll print all the elements that have been calculated after the execution of this block of code. So I have just written printf statement, and at last I have given the address of the third array p, because this array will be storing all the values that we have calculated. So if I'll run this code here, then you can see the output as enter the order of first matrix. So if I'll enter the order of first matrix as 2 cross 2, then it will display another message, enter the order of second matrix. So if I'll enter the order of second matrix as 2 cross 2, then it will display a message, enter the element 0 0. So suppose if I'll enter the elements 1, 2, 3 and 4, then it will display the message, enter the elements of the second matrix. And if I'll enter the elements such as 4, 3, 2 and 1, then it will display the output as, so this is the first matrix that we have entered, and these are the elements of the second matrix that we have entered, and the final product of that two matrices is 8, 5, 20 and 13. So this is how this program works. Thank you so much for watching. I'll be back with another video soon. Till then, keep watching.